Students, welcome to the Science 1 class. In this video, we are going to learn about periodic trends in properties. In the periodic table, the group 1 elements are hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Group 1 elements will have similar properties. Next to lithium, we have beryllium with atomic number 4, then boron with atomic number 5, carbon with atomic number 6, followed by nitrogen, oxygen, fluorine, neon, and then we have sodium. Here, the properties of sodium is similar to the properties of the lithium, and this is termed as periodic. Therefore, properties which repeats itself after a regular interval is called periodic, and this behavior is called periodicity. Under the heading periodic properties, we have 5 properties: atomic radius, ionic radius, ionization energy, electron affinity and electronegativity. First, we shall learn about atomic radius. You know that nucleus will be present in the center of an atom. So, the distance from the center of the nucleus to an outermost electron is called as atomic radius. Atomic radius of an element is defined as the distance between the center of its nucleus and the outermost shell containing the valence electron. Consider an atom containing more than one shell. For example, first shell containing 2 electrons and second shell contains 1 electron. To calculate the atomic radius of this atom, we should not calculate the distance between the nucleus and the electron present in the first shell. So, how we should calculate? We should calculate the distance between the nucleus and the electron present in the outermost shell, that is valence electron. In case if you are calculating the atomic radius in metals containing metallic bond, then it is called as metallic radius. You know that in metals only one type of atoms will be present. For example, copper metal will contain only copper atoms. Consider an homoatomic molecule bonded by covalent bond. When you calculate the distance from the center of the nucleus of one atom to the nucleus of another and dividing it by 2, we will get the atomic radius, and that radius is called as the covalent radius. For example, take a hydrogen molecule and it is made of 2 hydrogen atoms which is bonded together by covalent bond by sharing 1 electron each. Here, the distance between the 2 nucleus is 0.74 Armstrong. When you divide 0.74 Armstrong by 2, you will be getting 0.37 Armstrong. This 0.37 Armstrong is the atomic radius of one hydrogen atom. This atomic radius can be called as covalent radius. Now let's take the first group, that is alkali metals. In alkali metals we have hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. We have already learned how to write the electronic configuration. So, electronic configuration of hydrogen is 1s1. It has one shell. For lithium, it is 1s2, 2s1 and it has two shells. For sodium, 1s2, 2s2, 2p6, 3s1 and it has three shells. Potassium ends with 4s1 and has four shells. Rubidium ends with 5s1 and has five shells. Cesium ends with 6s1 and has six shells. Francium ends with 7s1 and has 7 cells. So, in the periodic table, when we move from top to bottom, atomic radius increases and the reason is number of orbits or shells increases. That's why atomic radius in group increases. Now, let's take the second period. In the second period, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Let's see the electronic configuration. Electronic configuration of lithium is 1s2, 2p1 and has two shells. For beryllium, it is 1s2, 2s2 and has two shells. Boron, 1s2, 2s2, 2p1 and has two shells. Carbon, 1s2, 2s2, 2p2 and has two shells. Nitrogen, 1s2, 2s2, 2p3 and has two shells. Oxygen, 1s2, 2s2, 2p4 and has two shells. Fluorine, 1s2, 2s2, 2p5 and has two shells. Neon, 1s2, 2s2, 2p6 and has two shells. So, in the second period, from lithium to neon, all the elements have only two shells. Let's take lithium. Its atomic number is 3. This 3 indicates that there are 3 protons and 3 electrons. The 3 protons will be present in the center of the nucleus and the electrons will be revolving around the nucleus. In the second shell, we have 1 electron. Next, beryllium and its atomic number is 4. So, it has 4 protons and 4 electrons. So, in the second shell, we have 2 electrons and the charge of the nucleus also increases. It is 4 plus. Next, boron. Its atomic number is 5 and has 5 protons and 5 electrons. In the second shell, we have 3 electrons and the charge of the nucleus increases. It is 5 plus. Here, the 5 protons present in the nucleus will strongly attract the 3 electrons in the second shell. So, when we move from left to right in the periodic table, atomic size decreases. And the reason is nuclear charge increases, and also electron addition takes place in the same second shell. Because of this, when we move from left to right in the periodic table, atomic size decreases. Let me sum up atomic radius. When we move from top to bottom in the periodic table, atomic radius increases, and the reason is number of shells increases. When we move from left to right in the periodic table, all the elements will have the same number of shells. Hence, the atomic radius decreases. Next, we will learn about ionic radius. Before learning about ionic radius, first we should know what is ion. So, ions are nothing but charged particles. For example, let's take sodium, and its atomic number is 11. So, it has 11 protons and 11 electrons. Number of positive charges and the number of negative charges are equal. Hence, the atom is neutral. Now, we are going to remove one electron from sodium. So, it will contain 11 protons and 10 electrons. Now, it will not be neutral because one proton will be excess. Hence, sodium will be represented as Na+. Cations are positively charged ions. Atomic radius of neutral sodium, that is, distance between the nucleus of sodium atom and its outermost electron, will be different from that of the sodium ion. The reason is, in the sodium ion, we will be removing one valence electron, that is, electron present in the outermost shell. So, while calculating the atomic radius of the sodium ion, we have to calculate the distance between the nucleus of the sodium ion and the second shell, not the third shell. Therefore, the size of a cation is always smaller than its corresponding neutral atom. That is, sodium ion will be smaller than the sodium atom. On the other side, let's take fluorine. Its atomic number is 9. 9 protons and 9 electrons. So, it's neutral. We are going to add one electron in the fluorine atom. Now, it will contain 9 protons and 10 electrons. It's not neutral because one electron will be excess. Hence, fluorine will be represented as F-. Anions are negatively charged ions. The size of the fluorine anion will be larger than that of the fluorine atom. The reason is, excess electron will be present in the anion and causes inner repulsion, which leads to increase in their size. Therefore, the size of anion is always larger than its corresponding neutral atom. Here, the atomic radius of lithium is 156 and the atomic radius of lithium ion is 90. As it is cation, the size of Li plus is smaller than that of lithium atom. The atomic radius of fluorine ion is 119 and the atomic radius of fluorine is 69. As it is anion, the size of F minus is larger than that of fluorine atom. Both atomic and ionic radius decreases when we move from left to right in a period. In the same way, when we move from top to bottom in a group, atomic and ionic radius increases. Okay students, that's all for today's class. In this video, we have learnt about atomic radius and ionic radii. Thank you students. Have a good day.